Good morning, everyone, and thank you very much for joining us for today's webinar, Building Blocks of Innovation, an introduction to generative AI for architects. My name is Felix, and I'm the webinar coordinator here at the Continuing Education Department at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from today. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. And now, just some housekeeping for today's webinar. Firstly, please note that today's webinar is being recorded. Secondly, to allow a reliable internet connection, please note that your microphones have been muted and that your cameras have been turned off. But if you have any questions for our speaker at any point, please use the Q&A window. Our speaker is going to address these questions at the end of the presentation. Please note that the chat will be turned off after the introduction. Also, to have the continuing education learning hours credited to your transcript, please note that an 80% attendance of this webinar is required. Please allow up to a few weeks for the hours to be confirmed and reported to your transcript. And lastly, please note that the presenter does not provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in discussions during the webinar. Before passing it over to our speaker, I would also like to point out that automated closed captioning is available to those members who need it. Please note that automated closed captioning service is also available in different languages. But now, we would like to thank our speaker for speaking with us today. Please welcome Juste Fanou. Juste has over 10 years of experience in specifications writing. As a senior specification writer, he has played a vital role in various projects, including institutional, commercial, and residential. Juste is passionate about sustainable design, and his expertise is often sought after by architectural firms seeking clarifications on contract documents, output specifications, or interpretation of technical standards. Beyond his spec writing work, Juste is the founder of Bibliotech, an app designing to promote healthy construction materials. Juste is also a member of CSC. And now, Juste, let's turn it over to you.
Good afternoon, everyone. Thank you so much for attending this webinar. Thank you for this great introduction, Felix. So without too much further ado, I would like to dive in. Today, we're going to be talking about AI, a big buzzword that has kind of like made waves last year in 2023 with the introduction of many generative AI tools. And we're just going to see how we can basically leverage them in what we do and how we've here at Bibliotech and at GMF Technical have been able to do so. So just a little bit about us. So I am the founder of GMF Technical Documentation Solutions and Bibliotech. GMF Technical Documentation Solutions is a specifications writing firm founded in 2012. We incorporated in 2016. We are very proud that most of our operations are technology driven. So we maintain a very small team, but we have been agile and trustworthy, and have been able to essentially work on very large scale projects in Ontario. We are dedicated to high performance construction and ecological and social responsibility. In 2020, at the height of the COVID-19 pandemic, we developed an app called Bibliotech, which is a research and education platform for architects. Some of you might know it, some of you might learn more about it during this webinar. So why are we here today? Today, I wanted to, when I put this presentation together, I wanted to dispel a couple of myths about AI, but I also wanted to make sure that people understood how these products work. It's not magic, it's more engineering and mathematics. And once you understand, I believe that once you understand how something works, you have a better ability to grasp its full potential and also make it work for you, i.e. adapt the features to your particular use cases. So generally, what we're looking at today is making sure that we get a clear understanding of AI, specifically generative AI, and we'll talk about how that's different from what's called discriminative AI and its applications in various fields. We'll talk about real-world applications of AI in construction through a case study called Techie. We'll also understand advanced techniques for prompt engineering and effective AI interaction. We'll talk about what that means, and we'll recognize the ethical implications and responsibilities associated with AI development and use. So the agenda is very straightforward. Introduce artificial intelligence, talk about generative AI, talk about large language models, i.e. things like ChatGPT, Bard, and other ones that are on the market. We'll talk about the Techie, our case study. We'll talk about prompt engineering and ethical considerations. As Felix has mentioned, please put all your questions in the question and answer box. And my colleague Sarah is on the call here. Hi, Sarah. She will be monitoring those and will be helping us at the end of the presentation to help me address them. Okay, let's get started. So what is artificial intelligence? I mean, it's funny because I think that we all get a sense of what it might be, but until I put this presentation together, I didn't really have a clear definition as to what it actually was. Also, in addition, I think that in popular culture, there have been many things, many movies, books, plays that have painted a certain picture of artificial intelligence, which, in many ways, science fiction can very well predict what actually happens in the real world. So you have examples ranging from Star Trek on the kind of like positive side, if you will, to extreme negative side, kind of like dystopian scenarios like The Matrix or perhaps even Terminator, right? So you kind of have like this artificial intelligence that is coming over, gets super intelligent, and then decides to take over the world. Like, what do we do about that? But let's define it. What's artificial intelligence? So this is a good definition that I found. Artificial intelligence leverages computers and machines to mimic, i.e., so they don't yet think, at least we don't think so, to mimic the problem-solving and decision-making capabilities of the human mind. So basically, what we're really trying to do is we're trying to essentially get a machine to do work that would have usually required human intervention or human intelligence to be able to be done. So if we understand how we as humans think, then we can kind of like program those into a machine and help the machine decide. Now, there are very, very early examples of quote unquote artificial intelligence dating back to, I think, even the 70s. Where researchers at IBM at MIT proposed a program called Lisa, which was supposed to be this therapist. You can actually find working versions online of this therapist. By today's standards, it's very, very outdated. But what this did is it had like a kind of like pre-programmed answers, and it was supposed to kind of like help you answer certain questions, but it always asked, leading questions. So it was like, oh, I don't feel well. And then it would answer, oh, well, tell me more about that. And then you say whatever. And then it'll say, oh, how did that make you feel? Like kind of like leading questions that a therapist would usually ask you. So this goes back a very, very long time. I think that in order to understand artificial intelligence, and over the last decade or so, there've been kind of like very rapid advances in AI. And it's important to break up some of these terms to be able to kind of like frame our discussion in a little bit better. So right now, I think that there are three big terms that are kind of like floated around. And I like to think of them as like subsets of each other. So on the first kind of like super high level, you have artificial intelligence, which basically tries to create systems that are capable of performing tasks that normally would require human intelligence, i.e. kind of like mimic what a human would do. And then down, so if you could think about that, like, you could essentially try to program some of these things in and then have hard rules like if then, if this, then that, if this, then that kind of thing. But we know that, like, oftentimes life is not that straightforward, and everything cannot be answered in just kind of like using these logic-based rules. So you have machine learning, which is a subset of artificial intelligence, where it's this kind of like subset of AI that is focused on developing algorithms that enable computers to learn and make decisions from data. So like, machine learning models are present everywhere now. They're quite pervasive in society for both good and bad, I would say. But a very kind of like simple example would be how, most smartphones now would be able to recognize certain faces, would be able to have like computer vision enabled. So you'd be able to search for certain things within your picture. So that would happen like a machine learning algorithm, which over time and based on like, a very large amount of data is able to recognize some of these things. And then you have deep learning, which is a subset of machine learning, which kind of like uses advanced neural networks, which are kind of like based on or structured to mimic the way neurons, the cells in our brains work, that take inputs and then based on different weights and factors, basically create outputs. So the computer is kind of like doing the work here, the processing work here, and based on the input, makes certain decisions and then provides you with an output. So these usually are very applicable to complex things like image recognition, speech recognition, etc., etc. So if we take a very, very brief and incomplete history of the artificial intelligence field, I think that we can kind of like start all the way back to the Imitation Game. It was a wonderful movie by I can never pronounce his name, Stephen Cumberbatch, the gentleman that does the actor that portrays Sherlock Holmes, the Netflix series, where he that portrays the life of Alan Turing, who was a genius mathematician, and who a lot of people say we owe the victory, the World War II's victory, to. And Turing, in 1950, released a paper called The Imitation Game. And what he basically, like, this was at the onset of computers, right? Like the onset of these kind of like, they were still very analog based. But he was asking, well, can machines think? And in his paper, he has a thought experiment where he says that, well, imagine you're in a room and then there are two other participants with you. One is a human, and then say the other one is a machine, like a computer program. And then your goal would be to figure out, well, which one is the machine and which one is the human. And over time, this kind of like test, if you will, has been kind of like the benchmark for artificial intelligence. It's called the Turing test. And when we will get to a stage, at least people posit that when we get to a stage when it is impossible to identify who's the human and who's the machine, then perhaps then machines would have then become intelligent. There are certain problems with that. I think that it was good for the early fields of the early works in artificial intelligence and computer science. But many argue now that, like, AI has become so advanced that you almost need to dumb it down a little bit, because in its ability to kind of like store information and produce information has become a little bit almost superhuman, if you will, and then no human would actually answer that way. So you almost have to scale it back to be able to make it believable that, like, okay, like this is a human and I can fool you. So if we kind of like go back to when was AI or artificial intelligence kind of like invented, if you will, or when was the term coined, we have to talk about the Dartmouth Summer Research Project. on artificial intelligence. And then that was the first time, a couple of professors from various fields, including math, psychology, engineering, got together and kind of like started thinking about like, okay, well, this is like a new discipline. And, how would we structure it? Like, what are the goals? What are we trying to achieve here? And then the goal was to explore and develop computational models and algorithms that can simulate human intelligence. So that would be, if you will, the birth of AI as a formal discipline. I probably think most of you have heard of this gentleman. He was in the news, I would say, last year quite a bit. Jeffrey Hinton. He was also at Coalition Toronto last year or the year before. And he's a British Canadian computer scientist, born in Britain, but most of his work has been done at the University of Toronto here. And he has basically, essentially, at his research lab, is responsible for a lot of the algorithms that underpin AI today, things like deep learning, neural networks, etc., etc. And his work has influenced so many fields, including machine translation. I don't know how many of you remember the early days of Google Translate. It was atrociously bad, but using deep learning methods, it has come quite a bit because translation is actually like a very interesting application of AI because, we all know that words in certain contexts have different meanings. So being able to kind of like transfer the nuances of certain words and phrases from one language to the other is actually quite hard. And it's a very specialized field. So with the help of AI, the translation field has advanced quite a bit. But why, I guess why we know a lot about him is because he recently resigned from his position at Google to be able to kind of like speak more freely and warn society about the dangers associated with artificial intelligence and how these systems could be co-opted by bad actors to effectively, trick society, things like deepfakes, misinformation produced at scale, etc., etc. So that's essentially his, that's the quest that he's on right now. And obviously, we all know about ChatGPT, and I've included this here because it's quite a milestone in what AI, I think this was the first time that we as a society were kind of like introduced to an AI agent, chatbot, whatever you call it, that seems to understand what it is that we're saying and can respond to what it is that we ask it to do in many kind of like different ways. So it's based on a technology called a large language model. And it's a fine-tuned version of previous model, at least the ChatGPT 3.5, I think, was a fine-tuned version of GPT-3. And GPT-3 stands for General Pre-trained Transformer. So using this transformer architecture, they were able to fine-tune it in a kind of like Q&A style, if you will, that was able to take user inputs and spit out like answers that were, that are, I should say, quite good. It's been one of the fastest growing, I guess, software in the world. They had 1 million users in just 5 days. I think that was overtaken by Threads recently, where they had like 1 million users in maybe an hour or something. Uses deep learning techniques to understand and generate human-like text. And was quite a significant leap in AI's ability to process and generate human language, right? And obviously, it freaked us all out because we're like, oh my God, can this thing now start doing my job? And, what is with somebody that has writer in their job title, you can think that I was quite alarmed. But at the same time, I'm going to talk about how, we view that more as an opportunity and how you should too. So let's talk about generative AI. Generative AI, like, what is that? What do we mean by generative AI, and how is that different from other things, other AIs out there? Generative AI is a paradigm shift in AI technology and artificial intelligence. And that's because AI models up until, things like ChatGPT and on the image generation side, things like Midjourney or DALL-E, AI models were discriminative in nature. And what I mean by discriminative is that you could tell an AI model, okay, I want you to find all the cats in this picture. So it has to find, it has to discriminate the cats from, like, say a dog or another item on the picture. So that's essentially what AI was good for. So it was good for things like sentiment analysis. So somebody gave me a Twitter review. Is this a good review or a bad review? It was good for finding things in pictures, for computer vision. It was good for classification. So if I needed, like, have like a product description, well, where in my inventory of products will this go into, right? So that was what AI was really, really good at. And in order to do that, you have to feed the model a lot of like good quality label training data, i.e., this is what a cat looks like. Here's 1,000 cats. Learn what a cat looks like, and then tell me that it's a cat and not a dog, basically. And in order to do that too, you have to provide supervised learning because sometimes the model would make mistakes. You have to correct the mistakes and then feed that information back into the model. So that was essentially what AI could do for a very, very long time. And then came onto the scene these generative models, which can essentially generate new content, right? So they're no longer classifying things or discriminating between things, but it generate entirely new content based on their acquired knowledge. So they learn all the patterns, and then now, based on those patterns, they can start saying, okay, here's something new that we're doing. So they kind of like synthesize all this information and then produce additional new information based on that. So that could do things like, write poems. If you've seen a lot of poems, you can write an entirely new poem. If it's used in other fields beyond text, like image generation, so DALL-E, Midjourney, but it's also starting to see use in audio creation, video production, basically anything that requires kind of like a creative aspect to it. These models, these generative models, can take on those tasks. And they're all underpinned by large language models, which we are gonna talk about, what are they and how do they work essentially. So just to kind of summarize, discriminate models classify or discriminate between different types of data instances based on their features. So they can classify whether something has a positive or negative sentiment, can determine whether something is an item or not, like i.e. whether it's a cat or not. And then generative models, on the other hand, can generate new data instances that resemble the training data based on learning that data distribution. So new pieces of text, new images based on large amounts of training data. But in order to do that, you essentially have to have like an enormous amount of data, like GPT-3 or ChatGPT was trained on essentially the entire open internet, right? So, if you kind of like, okay, like we need to feed it all of the world's knowledge to date for it to be able to do what it does. And obviously there are pros and cons to those approaches. So what are large language models and how do they work? So in order to understand large language model, well, we need to understand language model. What is a language model? So it's a type of computational algorithm for natural language processing, i.e., it needs to be able to understand natural language. So it's not just, like yes, no, but, it can take essentially pieces of text. Sorry about that. I thought my mute was on Do Not Disturb. It can take pieces of text and then predict the likelihood of new word sequences. It relies on statistical properties of language from large text data sets, and it's useful for various speech things such as speech recognition, machine translation, etc., etc. So that's what a language model is. So when you talk about the large language model, it's essentially that, but scaled to quite a few orders of magnitude. So it's a large general purpose model that can be pre-trained and fine-tuned for specific purposes. And I think this is really, really important, pre-training and fine-tuning, and we're going to talk about that. But one misconception about ChatGPT is that you can teach it new stuff. You can't teach any language model, any large language model, at least as they currently exist, any new information. It knows all it's ever going to know. And unless the lab that's behind the model, like, in this case, OpenAI, decides to train it on new information, that's essentially all that it's going to know. So that's why they have certain disadvantages. For example, like they're not necessarily current on world events. So if you ask ChatGPT, like, something that it hasn't been trained on, something that happened like, literally today or, yesterday, it might not know that because its knowledge cutoff is a certain date. I think right now it's maybe 2022 or 2023. I don't remember. But essentially, those models are, they're kind of like fixed in time with their knowledge. There are things that you can do to augment that. But, if you remember, GPT stands for Generative Pre-trained Transformer, i.e. pre-trained. So it's already trained. Like there's no more learning that the model can do. So how does it work? It's essentially a fancy text predictor. So given a prompt, i.e. an instruction, an LLM or large language model's job is to predict the next word. And they don't necessarily understand words, they understand tokens. And tokens are essentially portions of words. So in order to make these work, you have to usually break down the word into different portions. And depending on the language that you're studying, depending on the language that you're studying, these tokens are effectively, sorry, I was distracted by that call. Depending on the language that you're studying, these tokens are portions of the word. So for example, base might be broken down into BAS, S, and then E for whatever reason, for the purposes of learning the model, the language. I think OpenAI has a token counter. So if you put like a sentence into it, it will show you exactly how the tokens are broken down into. And so the LLM is trained on a very large corpus of text. And then it gives basically, because it knows so much, it basically predicts what the next text is. And then it gives the LLM the ability to reproduce human sounding text. Sorry, guys, I'm just gonna shut all my Teams so that this doesn't come up again. Apologies for that. Apologies. Okay, I shouldn't get any more messages. Okay, let's keep going. So how does that work? It's all a probability game. So, and in many ways, try to do this exercise in your head as well. If I told you the boy went to your brain will try to predict what that next word is. Like, if I stop there, I'm going to try to predict this. And I mean, like, we also have this, I guess some of us have this habit. I know I have it. When somebody's looking for their words, I will start suggesting words to them, right? Like I want to like finish their sentences for them because I know that, at the end of that sentence or that word that they're looking for is probably X or Y. And that's essentially what we're trying to reproduce with large language models, but based on probability. So if I said the boy went to what would come after that based on the context, right? So every time what the model does is that it takes the context, the boy went to looks for essentially all the words in the English language and assigns probability, right? Like, so it assigns a probability based on the previous context. So this might have been a sentence or a paragraph about playing, right? So if it's talking about playing, then what is the probability that like, these words will be the next words that will show up? So park works well if it's, about, playing or recreation, but hospital doesn't make sense, cafe doesn't make sense, airport doesn't make sense, playground might make sense too, because, it's very close to recreation and activities, that kind of stuff. And then it predicts that word. And then essentially what it does is that it just keeps looping that, right? So once it's at park, when it shows park, then it feeds in the boy went to the park into the model again and says, okay, predict the next word. And does that over and over again. And if you have enough computational power, then you can start having something that actually sounds, like English. And one way to have like a very basic, and this is nowhere close to a language model, but like a very basic way to test this is to, if you took like a WhatsApp or like a text SMS message on your phone, you have a text predictor, right? That says, once you type something, then it'll try to give you suggestions on what it does. The only difference between that and something like GPT is that the text predictor on your phone doesn't necessarily have the context. So if you keep typing suggestions, you start soon seeing that, like, the text predictor on your phone, basically the sentence stops making sense because it doesn't have the entire context to be able to predict what the next word is. It does it in like a very limited context window, if you will. So there are different types of LLMs out there, large language models out there. And depending on how you train them, you can do different things with them. So a base LLM, like kind of like in its raw, like most raw sense, and you can actually try this out on what's called the OpenAI Playground, is that is just a model. And what it does is that it just tries to basically complete sentences or tries to give you similar sounding things. So if you started a sentence, you gave a base LLM a sentence like once upon a time there was a unicorn, then it will just essentially continue that sentence no matter what instruction you gave it, and say like in a magical land called Eliza, and then the unicorn grew up to be happily ever after, because it's seen text that about unicorn and it's seen context that like unicorns are usually associated with fairy tales. Now, the problem is if you don't give it any instruction, if you kind of like just use the base LLM, if you give it a sentence like, what is the capital of France? Then, based on its training data, I will say, oh, what is the capital of France? Like, oh, I've seen that in like a lot of FAQs. I've seen those questions in a lot of like, questions about tourism. So, you probably want other similar questions. So it would probably continue and say, okay, what is France's largest city? What is France's population? What is the currency of France? So, I think that being able to generate human sounding text is the one step. But where we've kind of like pushed it is to give it the ability to, well, understand our instructions and be able to provide answers based on those instructions that were provided. So if you tune your instruction, and I give the analogy of, I borrowed this from the Google Introduction to Generative AI course, but they give the analogy of like, basically having like different types of dogs, right? So imagine that your base LLM is just like an untrained dog that, does dog things, but, does not follow instructions. An instruction tuned LLM, on the other hand, can say, okay, well, your job is to answer questions from the user, right? And then ChatGPT is actually an instruction tune or fine tune even LLM because, it can answer questions in the context, in the kind of like a chat context where you can kind of like talk to the machine and the machine will provide you with answers. So, if you say, what is the capital of France, to an instruction to LLM whose maybe purpose is to answer questions about capitals, you would say the capital of France is Paris. Now it's giving you an answer. It's not just finding similar sounding text, right? And then on the last kind of like step to this is to have a fine-tuned LLM. So this is similar to like a rescue dog or a police dog. This is like a very specialized large language model that can answer questions about very specialized fields. So for example, what are the requirements for a building to fall under Part 9 of the OBC? And then this is a real answer. This comes from our chatbot that is trained on the OBC. And it would answer, its name is Techie, and it would answer that part 9 of the Ontario Building Codes applying to buildings. I mean, the following criteria, etc, etc, etc. So now it's very specific in its domain. It only knows about the OBC and can only answer questions based on the OBC, Ontario Building Code. So to recap here, we have base LLM, who are kind of like just pre-trained models on very large scales of data sets. They're versatile and general purpose, and then they have like very limited task-specific performance. So examples are like things like GPT-3, 3.5, 4, and again, like not ChatGPT because it's different, because ChatGPT is actually like a instruction tune or fine-tuned version of these kind of like base models. Instruction tuned LLMs, they have task-specific instructions. They have improved performance on specific tasks, and then they can do different tasks. So ChatGPT is an example. And then you have fine-tune, which are like very specialized in their domain, higher task-specific performance, and then domain-specific generation capabilities. And OBC Techie is an example here. I put an asterisk here because, like, for anybody who's very technical in this field right now, they would probably tell me that we did not technically fine-tune Techie. It uses like something else called retrieval augmented generation, which I will touch on in the next topic. But for the purposes of this this slide, this is a good enough approximation, if you will. So hallucinations. So we've probably heard the story of this lawyer that used ChatGPT, and then ChatGPT just kind of like started making up cases that they provided to the judge, and the judge basically, like, I think they either fined them or did something. But we've heard of ChatGPT, or we've heard about the warnings of ChatGPT kind of like making stuff up and sounding very, very confident about it. And then those are called hallucination. So a hallucination occurs when an LLM generates information that appears to be real or plausible, but is actually false or invented. And then the problem with this is that, remember, like, its job is to predict the next word, right? So if you said, what is the current president of the US, for example, as like a question, and say it didn't know, but it seemed plausible that this president of the US would be Bill Clinton because it saw it in its training information, it will just kind of like fit that in, and you will say it. So the problem with AI and LLMs, at least LLMs right now, is that they don't actually know what they're saying. They're just predicting these words, right? So I think that, like, we're still at a stage like this, they're still in their infancy. So we're still at a stage where these models need quite a bit of like supervision. And if you intend to use them for any kind of like, anything serious in your application, any kind of like mission critical items, like, you need to have a human in the loop that is checking what these models are doing or saying, basically. So that's what a hallucination is. So basically, that's when LLMs generate text that goes beyond their training data, or when they try to fill in the gaps with invented details that are not aligned with reality. So what I say is always fact check what an LLM is telling you. So if you have, if you're using ChatGPT, or if you're using Techie, usually I tell people that it's a starting point. So it's like a way to start the discussion. It's a way to kind of like narrow down your field of choices. But always fact check, always go back and check to make sure that, like, the information that you've been provided with is actually factual. So they can help. I'm not in the camp of those who kind of like dismiss them entirely. Just because, like, they're not perfect yet. Nothing is. But at the same time, like, knowing what the risks are with using them can actually help you quite a lot. Okay, so we've talked about text, and I know that we're all we have a lot of architects in this audience, and probably maybe when you heard about this presentation, you were like, looking forward to learning more about things like, Midjourney or DALL-E or what have you. So that's a completely different field, even though they're related. I'm not as knowledgeable in image generation, but I can definitely certainly touch on it. And when I was putting this presentation together, I was like, okay, well, I can't not talk about image generation in these slides. So this is what we're gonna talk about now. So how do they work? So again, like I always want us to understand how these things work so that we can use them better. So essentially what an image generation model does is that there are different, okay, so to be fair, there are different ways to achieve image generation. But the most popular right now that underpins like a lot of the models that we've seen or we've used, like Midjourney or DALL-E or Stable Diffusion, use basically what's called diffusion. And the way this works is that you essentially train a model to take a picture and then gradually add noise to the picture. So gradually basically blur out this picture by adding noise to the point where this image just becomes pure noise. So once you have that, that's the easy part. Everybody can do that. Like, I mean, I can do that in Photoshop if you wanted me to. I can give you noise. The hard part is to denoise the image, right? So now you train the model to basically go, so this is called the forward diffusion phase. And then you train the model to go back from noise back to the image of the dog. And then that's where it becomes hard, right? So basically what the model does is that as it learning to basically incrementally, step by step, right? So it just adds a little bit of noise incrementally as it goes to pure noise. Then it also learns the reverse process. Like, how do I go from just pure noise to the picture of a dog, right? And so that's effectively what how a diffusion model works. And once you have that, then you can kind of like, if you will, couple that with learning that this image actually represents a dog, right? So now you can imagine how like putting an LLM with these models together, you can get something like get me a picture of a dog that looks black and white or something like that. And obviously with enough data of what a dog looks like, what a building looks like, what a, what have you, then, you get to the point where, these things can generate like entirely novel images. So going back, basically there's two phases, the forward diffusion phase and the reverse diffusion phase. In the forward diffusion phase, the model gradually adds noise to an image over several iterations and transforms the image into a fully noisy state. So the noise addition process is predictable and reversible. And then in the reverse diffusion phase, the model basically iteratively removes the noise and learns to predict the reverse noise. And that way, basically, over time, the model can start, learning that, like, this is how you draw, quote unquote, I say that very loosely, a dog, right? So it would be very, and I think that one thing that I've learned is that the way these models are implemented, they're very different from, human thought or human processes, right? Like, there's no way that like a human, you'd ask a human to draw you a dog and then like, it's like, oh yeah, I know how they're gonna do it. I'm gonna start from like, noise and try to remove the noise, right? So the intelligence, this synthetic intelligence that we're developing is very, very different from human intelligence. Is it intelligence? I mean, that's like a philosophical discussion that I'm perhaps not ready to have yet. But anyway, forward diffusion, adding noise, reverse diffusion, getting back to image, and then that's how we get that these wonderful images that we've been seeing. So obviously that has led to text to image models that basically combine the power of diffusion models, as I've shown, with LLMs, large language models, because large language models actually, try to understand and interpret human text. And then they're basically able to generate kind of like context-aware novel images. Players in the field include things like Stable Diffusion. Meta has a model, DALL-E 3 from OpenAI, Midjourney, etc., etc. So both of these images are AI generated. And, it's like, I just put in, DALL-E 3, like, give me an architectural visualization of Toronto in the year 2050. apparently we're gonna have lots of drones. And then, then I said, oh, well, modify the image and make it in the style of Zaha Hadid, right? So, it knows who one doesn't know, but at least it's seen in context, buildings that have been, designed by Zaha Hadid. So it's kind of like, creating things that have like more curves, et cetera, et cetera. So this is where, this is basically essentially how they work. Diffusion models are not the only type of models out there for image generation. There are things called generative adversarial networks. And then the way these models work is by kind of like having what you call a discriminator model and a generator model, right? So the generator model basically generates a face using deep learning algorithms. And then the discriminator model takes that against a real face and then tells, whether it's a real or a fake face, whether it was generated or not. And then, using, machine learning and deep learning over time, the discriminator is not able to tell the difference between the synthetic face, if you will, and the real face, right? So, I mean, I'm sure you've heard things like deep fakes, for example. So that's how those were developed over time. So it's basically the idea that like you have this like, and I mean, it's still very much, it still uses like some discriminative AI to be able to do it, but you basically have two adversarial networks that are kind of like competing against each other to tell you whether a face is or like a picture is real or generated by an AI model. Variational autoencoders. So those, they encode input data and compress that information, and then, basically decode that data to reconstruct the model. So, if you take like a certain image, it will basically turn that into like data and weights, and then the decoder can take that data and weights and then turn that back into a picture. So those are, other types of models that I wanted to touch on, but definitely not the most popular right now. Okay, so let's talk about Techie. Techie, what is Techie? Techie is an OBC-based bot, not only on the OBC actually, because we are now kind of like starting to work with suppliers and manufacturers to have Techie kind of like deployed onto their profiles on Bibliotech. But when we saw like the power that generative AI had, and especially large language models, we said, okay, well, how can we build something of value for our users? So what this bot does is that it's basically trained on the OBC. And again, I use the word training very loosely because I'll show you what it actually does in the back end. We got 100 plus users in a few weeks. That was very, very exciting. Uses GPT-4 as a reasoning engine. A lot of people are very happy with the answers that it provides them. But like all language models at this time, it can sometimes suffer from hallucinations. I don't have enough time to do like a live version now, but after the webinar, I'm more than happy to send you a link to how you can try this for yourself. But you can see here in this video, this is the Techie basically answering a question from, this is actually a BCIN question from the Humber booklet, I think, where it's like, for a large story farm, where do I find this information in the building code? But you can actually see the reasoning process of the model, where it kind of like says, oh, well, it's not this, so it must be this kind of thing. So very, very cool stuff. We're very proud of it. So how does this work? So basically, all that it does is that it finds context in the building code for the question that you're asking and then provides you that answer. So in order to do that, well, we have to understand how lexical search and semantic search works. And basically, what is lexical search and what is semantic search? So very, very early advance of the internet, and maybe probably how like a lot of search in a lot of software on your computer works, say like Bluebeam or Adobe PDF. Like, if you're looking for something in a large document or you're looking for something in a drawing, you go Control F and then you type in what it is that you're looking for. So for example, you're looking for, I don't know, the kitchen on a set of plans, right? So if you type kitchen, then, it'll show you everywhere where that like word appears. The problem with that is that if somebody called it something else, then you have an issue. If somebody made a typo, you have an issue because you're not going to get any hits, right? So lexical search basically matches words to basically possible answers in a corpus of text, right? So if I ask the question, where was the last word cup? And these were our possible answers, then, we can see how many matches from this original word we have in each of these answers, right? So this sentence says the last World Cup was in Qatar. So we have 5 matches. The sky is blue is 1 match. The bear lives in the woods. So we have done 2 matches, and an apple is a fruit. 0 matches. So now we can see that, oh, okay, well, this is likely the most correct answer because it has this most amount of words from the original text, right? The issue with this, though, is that if we have things that are spelled exactly the same but mean different things, then we could have like false positives, right? So if I say where would the last World Cup and I have the same I have these as possible answers. So the previous World Cup was in Qatar, same as previous. 4. The cup is where you left it, right? So this is probably not talking about the World Cup, but it has 3 matches. And then if I also have like a sentence that says, where in the world is my last cup of coffee? This has 5 matches, which is actually technically more than this answer, which is talking about the previous World Cup being in Qatar, right? So if I use purely lexical search, then this is likely going to be my most likely candidate for a possible answer. So we can clearly see that there are limitations as to how using this method. But it's still very, very popular. I mean, it does the job for the most part. Like, things like your Adobe PDF or whatchamacallit, Bluebeam or Microsoft Word. Whenever you hit Control F in a piece of software, this is basically what it does, right? Now, based on the technology that we have today, we can use things like semantic search. And semantic search is more advanced in that it analyzes the context and it goes beyond matching keywords. It focuses on understanding the meaning and intents behind a search and then analyzes the relationship between words and sentences to provide you with an answer. So how in the world does a computer know what a World Cup is and how it's different from a cup of coffee, right? And then that's where we need to get at. We need to understand the semantics behind those words, i.e. the meanings, in order to actually provide these kind of like context-aware LLMs, if you will. So in order to do that, the computer uses something called embeddings. So embeddings it took me a hard time to, I guess, understand them or even visualize them. But embeddings are essentially addresses for words. And given a large enough corpus of text, a computer can start essentially providing codes for words and using basically matrices and providing these addresses. It can kind of like see where certain words are closer together than others, right? So this is very, very, some embedding models have hundreds and hundreds of dimensions. I'm just showing this in 2 dimensions. But basically, imagine that we had soccer ball at this embedding address. Then what the model will do is that it will also embed basketball or tennis ball close to soccer ball, right? So that it knows that all these balls are kind of together. Similar with apples, right? Like apples, cherries, and bananas, they're all fruits. So they'll have similar or at least close by embedding addresses. Cars and trucks will be together because they're vehicles. Houses, commercial buildings, etc. will be together because they're structures, that kind of thing. So that's what the model does. The model basically turns all the text into numerical addresses for the words and basically looks for these numerical addresses when you're kind of asking it to find something. Right, so it's embeddings a numerical representation of language elements, i.e. word, phrases, text, etc. Translate language into vectors in high dimensional space. So again, I'm showing this in 2 dimensions for the purposes of just explaining what it is that we're doing. but some of the embedding models that we have like hundreds, if not thousands, of dimensions. And then during this process, what the model does is that it's able to capture semantic and syntactic relationships. So it's kind of like starting to understand that, like, all these balls are associated with sports. All these are associated with fruits. All these are associated with a building, etc., etc. So that enables LLMs to process and understand complex language patterns. So now, if I use something called retrieval augmented generation, i.e., using embeddings with my question over a large corpus of text, then if I say, where was the large word cup, it would have embedded my text with all these addresses, and then it would have found that, like, when they were talking about soccer and cups and stadiums and stuff like that, all that stuff went together. But there might have been another portion of the text that was talking about Starbucks and coffee and whatnot. They would have embedded it, like, kind of like further away from that, and same with, like, fruits and apples. So now when I ask that question, it would find the proper context and then give me the proper answer for it. So that's kind of like, very, very high level. That's how, like, embeddings work. And then this is what we do with Techie, essentially. So with Techie, what we do is, we fed it the OBC, and it uses this GPT-4, and whenever a user asks it questions, it has the entire OBC embedded in it, if you will, and it seeks relevant passages from the OBC that might make sense to answer that user's question. So as long as the query and the relevant document are somewhat close together, embedded together very closely, then it will feed that information within that context to the user. The limitations of this approach is that, oftentimes you'll find that, like, the model misses stuff. So this is really important for things like building codes, because almost every sentence in the building code is like, except as provided by sentence 234, then you can do this, right? And except this sentence, and provided this sentence doesn't contradict with it, kind of thing. So creating that logic, if you will, becomes quite hard, because the model will find, oh, you're looking for, I don't know, fire rated doors, here it is, but it might also not find the the exception within that. And we're working really, really hard on that, but I think that the ultimate solution will be a lexical search and semantic search hybrid, to be able to get to a point where it's more useful in the sense that it provides information, but it's also kind of like able to do some of that kind of like keyword matching search, if you will. So retrieval augmented generation, which is what we do with Techie, and which is what, like, other things are based on, are basically try to overcome, like, limitations of LLMs that have fixed data sets. Because remember, I said that GPT stands for Generative Pre-trained Transformer. So that means that the models have fixed data sets, so they contain their knowledge is essentially all contained within their training data. They cannot update or access new information after they're trained. But if you do something like retrieval augmented generation, then you can combine the power of the language models with external data retrieval. I think Bing does this as well. So it has kind of like GPT as its core, but then it can also browse the web and then kind of like give you more information based on the context that it was provided. It can enhance LLM responses by providing up-to-date information, obviously overcome the static nature of the LLMs. And it basically uses these generative capabilities, i.e. making human-sounding text with factual correctness, right? So that's kind of like, in a nutshell, that's what we're doing for Techie, but it's also kind of like how people have been able to overcome this issue that, like, hey, I have this ChatGPT is great, but it doesn't know enough about my company, or it doesn't know enough about what it is that I do, right? So by using retrieval augmented generation, you can overcome that. Okay, so before we part ways, I think we're 1 hour in. Like, now I'm just going to talk a little bit about prompt engineering, i.e. how do we actually give like how do we talk to these models? Because they're quite new, and I think that there's still quite a lot of training and awareness that has to go on. So we are very kind of like we're like in the infancy of this field. And remember, when computers were first introduced, it was all, MS-DOS, or even, better than that, like you had to basically program the computer, and there were only like, certain quote unquote experts that could do that. And over time, like, we kind of like created new interfaces and understood like, that like, the human computer interface could be better, right? Like, Windows, like, Bill Gates made all his money and kind of like developing this visual operating system, if you will. So I think that we're like, the field is going to grow quite a bit. But I thought that like I would give the participants of this webinar, a couple of like, tips on how to use these models. So that's that field, if you will. I wouldn't really call it a field because it's really just linguistics. But we've given it the name. We call it prompt engineering. Has nothing to do with engineering. But if you're good with language, you're actually going to be quite good with like interacting with these models, if you will. So here are a couple of techniques. So in order to get the most accurate answers from a large language model, it's important to be very clear. It's important to, remove ambiguity, provide enough context that like, the language model will know what it is that you're talking about. With Techie, for example, I've seen people go in and like say fire rating. Well, like, I asked that, I'm like, I ask myself, well, would you really tell that to a human, just fire rating, building code fire rating? Well, you wouldn't, right? Like, it's not like, you would have a problem, you would have some context to the problem, and then you would have a question, right? So if you frame your prompts in like, okay, here's a context, here's a problem that I'm facing, and here's what I want you to do, then you're more likely to get like very, very, or a lot more accurate answers. And sometimes people just in frustration, they're like, oh, this thing is useless. It doesn't even understand what it is that I'm trying to tell it. But I think that is just a matter of, making sure that you have enough context and your instructions are clear enough to be able to get to what you want to do. And that's a skill unto itself. Like there's no doubt about that. Like I think you get better with practice. Provide reference text or context. So sometimes if you want information about a specific piece of text, or you're trying to kind of like provide information within a certain time frame, well, provide the reference text. Say, here is the text that I'm looking at. Like I want you to do this, I want you to do that. Just like humans, sometimes these models, like if you have a problem and then you have questions about that problems, what you would likely want to do is break that problem into simpler tasks. So if you want the model to do something very complex, then maybe like split that into like more simple tasks for the model to do. So solve one, then solve two. And then the other thing too is, last but not least, is give the model time to think. And apparently there's this magical phrase: if you have like a very complicated problem and you say, let's think step by step, what the model will do is that it will actually not jump to a conclusion, because it has a tendency, because it's just trying to, on the fly, generate all these words. If you say, do this step by step, then it will actually like, use like a logic-based way to answer your problem. So here's like a couple of like examples. Who's president? Instead of saying that, you say, who was the president of the US in 2021? Summarize the meeting notes. Instead of saying that, just do it in a single paragraph. So you're kind of like stating what your required output is, then, do a list of speakers, So your instructions are very clear. How do I add numbers in Excel? Instead of saying that, like, how do I add up a row of dollar amounts in Excel, etc., etc. So that kind of like gives the model more context and more specificity as to what it is that you're trying to do. Then there's something called few-shot prompting. So that is when you give the model an example of what it is, or the expectation of the output. So you would say, hey, summarize the following paragraphs for a news article, or summarize the following news article. Here are a few examples. So here are like a few examples of what I've done, and you provide as many as you want, but usually like 2 or 3 is sufficient. And then you say, okay, here's your new article to summarize. Here's the excerpt, and then write me the summary, right? So now it will learn very quickly from the examples that you've provided, and then it will be able to kind of like give you something in the same format as what you've provided previously. So let's talk about ethical consideration and dilemmas. So now that we've talked about all the technical aspects of it, if you will, I think that the implementation of AI should be done very, very carefully, or else it can have disastrous impacts on society. So there are a few examples and case studies that I want to bring up. So this quote is from the Introduction to Responsible AI from Google Skills. But basically what they're saying is that without responsible AI practices, even seemingly innocuous AI use cases or those with good intent could cause ethical issues or unintended outcomes. So we need to develop technologies with ethics in mind, and that is important for societal impact and people's lives. So there are a few examples. I don't know if we remember this, but this was from Amazon, and they had developed an AI system for basically scoring potential candidates. And what they found out is that the model, so they kind of like gave it all resumes for people that had done well at the company. And then what they realized is that the model was favoring men over women. And anyone with a female sounding name would automatically get rejected. And anyone with a male sounding name would automatically, not automatically, but like would be more likely to get hired. So that's kind of like an example of like the model reflecting the biases in the training data. And that is also why it's really important for, in order to develop AI ethically and responsibly, it needs to be open, right? Like we need to have access to, we need to be able to query or audit the training data. We're not there yet. I don't think we'll ever get there yet. We'll ever get there. But the issue is essentially that, like, as for example, like this model, it said, oh, well, it looks like, the men are doing better than the women. So that must mean that men are better than women. Therefore, I'm just going to reject kind of like women. So obviously, like, if we feed, like, it's a garbage in, a garbage out situation. So if we feed models with data that is corrupted or data that is biased, then they're gonna like reflect those in their applications. These are two great, this is a book, this is a movie, Weapons of Mass Destruction and Coded Bias. And Weapons of Mass Destruction is a great book from Kathy O'Neill, who's a mathematician. And then she analyzes how we use big data and algorithms in a variety of fields like insurance, advertising, education, and how they can kind of like, these algorithms can amplify things that harm disadvantaged people in society, like the poor, reinforce racism, amplify inequality, etc., because over the years, we've kind of like, society has implicit biases in them. So for example, somebody being denied insurance because, or being quoted a higher insurance because of their postal code, or somebody being denied a job because of their first name, etc. Coded Bias is a very fascinating a documentary where this MIT student was working AI, and she found that, like, she was working with facial recognition algorithms, and she found that, like, because she had that dark skin, the models wouldn't recognize her. So she started asking questions, and then she realized that, the models were trained on people with lighter complexion. So, there's kind of like that discrimination that is ingrained in the model. And then they go into all these things about how, like, then you're kind of like deploying these imperfect models at scale to do things like, um, like national security and whatnot, and surveillance. It's quite fascinating, actually. So definitely recommend those two pieces of text, or sorry, this text and this movie, if you get a chance, if you want to learn more. And we also need to know what the human cost is of training these models. I'm not sure if you remember this, but there was like something in the news about how essentially, in order to make ChatGPT better, you have to use this thing called reinforcement learning with human feedback. And that is essentially models, because again, like at first they're just trained to just spew out human words, and then like they basically get like a human person to rate whether that was a good answer or not. But without any kind of like fine-tuning, if you will, these models can spew out very toxic stuff, racist stuff, horrible stuff, and then you kind of have to say, no, 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 don't respond this way. You need to respond this way, kind of thing. So they have to be people that do that, right? So, and OpenAI actually hired like a bunch of like people from Kenya, who are very low paid and were kind of like exposed to like this extremely toxic content, which led to like long-term like psychological damage to the people who were kind of like monitoring these models, if you will. So definitely something to consider as well. Copyright, big thing, big deal for in our profession as well. If a model can just generate a picture of a building and then somebody builds it, hires an architect to build it, who owns the copyright? What if your building was used to train an AI model, right? Like, do you then have to, do you have the ability to get compensation for it, right? So I think that in order to be fair, equitable, and ethical, those are all things that we need to consider. Lots and lots of like lawsuits right now. But I think that, the law around copyright will need like, a serious updates in this age of generative AI, because the lines are quite blurred right now. Carbon footprint is also very important. All of these things that we do in the cloud, AI, they are hugely resource intensive. And if we're gonna, talk about actually shrinking our carbon footprints, then we also have to kind of like talk about how to make this more ecologically responsible. Heard that it takes about like the same amount of power that you would use to charge your phone to just generate one picture from like a model like Midjourney. And I think that that power consumption is going to go up over the years. So it's very unclear what the carbon footprint of these models are right now because they're so new. But it's definitely not something that we can afford to ignore, given the state of where we are in the environment. The last big question or topic that I'm gonna leave you with is, like everybody has this question on their mind is, will AI take my job? And I've asked myself the same question, as I said. Like, I think the first time I learned about GPT-3, not ChatGPT, but GPT-3, basically like the base model that could kind of like just produce text, with somebody with writer in their job title, I'm a specifications writer. I was like, okay, that's it. I don't need to work anymore. And like, my clients are just going to use this and they're not going to need spec writers anymore, etc., etc. And I think that's normal, that's human. I think we have to protect what we do, and I think that we all bring very important things to the table. But I think that we also have to look at history and look at how technology and history have kind of like, interacted in the past, and see whether we can predict something about the future, a future in which we'll have AI. So generally, technological advancement has not led to widespread unemployment. We have moved from agrarian to industrial to service, now information economy, without having mass job extinction. Usually what happens is that you have new categories of job that get created. If we look at ATMs in the 1970s, what happened actually is that the cost of branches running a bank or branch decreased, and then you had more branches opening because you didn't have to spend that much per branch, and then you actually employed more tellers. But there was a very widespread fear that like, the ATMs or automatic teller machines would basically replace all the tellers, and the tellers wouldn't have anything to do. But if you go to any bank today, you have the ATM, but you still have a lot of tellers, right? And then, if you look at some of the world's most roboticized nations, and, we use that term, I borrowed that from Peter Diamandis, who's a blogger and writer in that AI space. So he says that, like, those are nations with the most penetration of robotics. So things like self-driving cars, self-driving trucks, that kind of stuff. So things like Germany, South Korea, and Sweden. they have some of the world's lowest unemployment rates, right? So oftentimes what happens is that when you bring automation, when you bring technology, what you do is you actually like increase capacity. You don't necessarily like reduce the number of people needing jobs. And I think we all kind of like agree that like we're in somewhat of a labor shortage right now, despite all these advancements in AI. So oftentimes what happens is that like capacity is increased and we actually need more people to be able to do these jobs. Now, will some jobs disappear? Absolutely. Some jobs will become extinct, but there'll be new categories of work that will emerge. So for example, the internet created 2.6 new jobs for everyone that was eliminated. And then obviously you can look up all this information on this blog. That's where I'm quoting from. But up until the last decade, like what was an influencer? We didn't know what that was. You think about like all the opportunities in self-employment, like all these coaches that are out there. That didn't exist a couple of decades ago. You think about like even graphic design, like introducing things like mobile, kind of like created new categories of graphic designers who were just focused on this new technology, and that created more jobs than there were before. So I think that there will be a need to have a shift towards new technological fluency, obviously, and AI will be kind of like our smart collaborator. So you think of GPT or ChatGPT or whatever AI that it is that we're using, is going to be like a very smart intern that can assist as we are, doing our work. But obviously, retraining workforce, raising awareness, and basically providing the ability for people to retrain and reskill in these new job categories is going to be very, very, very important. And then with that, I'm going to open up the Q&A session, and I hope you learned something. Thank you very much.
No, thank you, Just, very much for the very interesting presentation. And just a reminder to our members, if you do have questions, please post them into the Q&A window. Just is going to address all these questions now.
Okay, sounds good. Let me just go back. So the first question is, do AI machines have large sizes as earlier computers? So I think the answer is they're all stored in data centers. Now, I don't know what the ratio of like computational capacity to size of the machine will be. But I think that we've come a long way since like those large mainframe computers, if you will. So yes, the answer is like they're all stored in data centers. I think that like you need a lot more compute than computers that you and I have to be able to run some of these large language models. But some people have been able to kind of like use smaller language models and run them locally on their computers. Funnily enough, like gaming computers are the best computers to be able to kind of like do the work that you require for artificial intelligence, and specifically generative AI. The other question from Alan Humphreys: has Zaha Hadid or any other human content creator been compensated for the use of their intellectual property to train the AIs? So that is the question that we talked about in the copyright slide. So the answer is like the law is ongoing right now, and it's hey, I think that it will need to be rewritten. But I think that you're right. I think that in order to develop this AI in an ethical and equitable way, I think that the human creators need to be compensated. What that's going to look like, I don't know, and unfortunately, I don't have that answer. Another question. If you produce a design and ask an AI to generate a perspective from the designs, who owns the perspective image created? Alan, I wish I had that answer, but that answer will need to be answered by the lawyers and the law. I have no idea, and I don't know what the current status of the law says right now. Randy Wilson, is Techie currently set up on the most recent issue of the OBC? So we state at the bottom of the Techie, and I can probably show this. If you go to the Techie chat window, we will state what version of the OBC we're using. So this is under bibliotech.ca, OBC Techie. This is not an official version of the Ontario Building Code, and then it is trained on this version. So that is the ELOS currency date. So you can always see what version of the building code that we're using. We try to update that as often as necessary, but we are trying also to be as transparent to our users as possible. Alan Humphreys, the language used in the Ontario building code is not necessarily what is used to refer to the same item condition common using. Does Taki offer suggestions on how to translate common usage in code speak so the results are valid? I think Techie understands some of the nuances used in the building code. It also has the definitions available to it. The best way to kind of like get the best out of Techie is essentially ask it questions, ask it to clarify things. I think that the best way to learn to use these models is to interact with them. So, and yes, you're right. But like Techie does have the definitions, if you will, available to it. So, what is a building in code parlance might be different. And if you remember when I talked about prompt engineering, providing context is really, really important. And as well as, how you want to structure the output. So that's from Alan. From Huda, Juma. Hello, I think listening to your lecture, the architect needs to prepare a library of standard name and groups to classify grouping and standardize the meaning of each word model. I'm not sure I understand the question, Huda. So and perhaps I think I need to do a better job actually like listing out the question. And for those of us who are joining us on the phone, so Huda says, I think listening to your lecture, the architect needs to prepare a library of standard name and groups to classify grouping and to standardize to the meaning of each word or model, maybe using something like ISO 9000 to standardize the libraries if we want these models to be used internationally. So I think that that's not required because of what I talked about in embeddings. So when you embed something, the model kind of like learns relationships between those words. So if you're speaking, like if you embed, say, like a British standard, it would understand those word relationships in British English versus US English. So I don't think there's a need to actually do that at all, no. So another question from anonymous attendee, is the other unsaid side of this program to teach us users how to speak to it? I do not understand the question. Like if you're asking whether some of this presentation is to teach users how to use large language models, I would say yes. One of the objectives is to teach users how to use large language models. If it's if you have another question, then perhaps I will ask you to clarify. Question from Jin Lu. After this webinar, how can I have the certificate for OA structural continuing education hours? So that I'll leave Felix to answer that question. I think Felix will email certificates.
Of course, just no problem. Let me help you. No, the OAA does not issue certificates, but instead the OAA reports the attendance of this webinar directly to your transcripts in. Thank you.
Okay, there you go. Will we be able to discuss the confidentiality and privacy concerns with using generative AI? This has been a big topic, a hot topic in the AEC community recently. Yes, obviously, but I think that the privacy concerns and confidentiality concerns are exactly the same as using any kind of like cloud-based software. So I think that it's important to read the terms and conditions of any website or software that you use to see how they use your data and how that data is being stored. So I think that if you're planning to use, Techie, or you're planning to use OpenAI's GPT or Midjourney or what have you, you need to read the terms and conditions of each provider and effectively see if that's suitable for you. If it's not, then really don't use it. But effectively, anything that we use on the cloud is being sent to a server and sent back to us. So there's obvious risks in that happening unless you store all that information locally. But I think that with just a huge amount of computes and data storage that we require these days, it has proven that it's not very practical, if you will. From Alan Humphreys, whose morals, ethics do we use to train AIs? Who makes that decision? How do we find out what we use for training? That's a very good question, Alan. I think that there are, again, because the legislation is essentially in its infancy, there are certain things that have been kind of like used to train AI to basically guide AI on ethics and rationality. Um, I think that the UN Convention of Human Rights was used on some models, but we haven't decided that yet. I know that in the European Union, they have created the first draft of what they want to call an AI Act, what you shall and shall not do with AI. So, that might become a guiding document for these companies and or for other legislation in other places in the world. I believe China also has something around AI use and ethics. But no, that's a very good point. I think that even as humans, it's a very big philosophical discussion. It's like, whose morality or ethics do we use to even guide our daily lives, right? So I think depending on who you are, what your belief system is, and all that good stuff, that can become like quite a conversation to have. But that's a great question. Charles Azar. Can those machines that learn how to assess the language, figures, and situation based on the original program, can they be reprogrammed to think differently? I think it will depend. I think I'll need a little bit more context to answer that question. Can you retrain an LLM? Probably no. That's the answer. Can you train an AI with more context, with more information? Yes. So I think it really depends on, where you are. Remember at the beginning of the program, we talked about AI and machine learning and deep learning. And so I think that depending on where you are, but can you retrain a model? Yeah, absolutely. But I think that the computational costs and ecological costs are so great that it's not something that you want to do continuously, at least in the case of large language models. But can they be done by a random user? Can somebody randomly kind of retrain GPT so that it becomes toxic? I think that unless they hack OpenAI and train an entirely new model, the answer to that is no. Thank you for the helpful presentation. It was very easy to follow. You're very welcome. I'm so glad to hear that. Charles Azar, are there any legislative efforts to ensure people know with a warning or disclaimer that the answer assessment is coming from a machine rather than a human being? That's a very good point. So I think that in the draft AI legislation that has been penned into EU, one of the requirements was to say that hey, whenever you're using AI, you need to make that clear. You need to have that sense of transparency so that your users know that they're speaking to a machine. I think that's speaking to ChatGPT. I think that you generally that this is an AI, but there are other applications, right? Because we have, for example, at JMF, we have certain applications where we send something to OpenAI and then it provides an output. So at that point, and maybe even sends an email, right? So at that point, you kind of want to say, oh, this was written by an AI or written by Techie or whatever you have. But I think that it's good practice, absolutely. Yes. Now I think that ChatGPT in the OpenAI platform does warn you that this can provide non-factual information. And we have the same thing at the bottom of the Techie window over here. So it says that all large language models, it can provide occasionally inaccurate information and is provided without any warranties, et cetera, et cetera. So I think that the good practice is to always warn users that this information might be coming from an AI, and especially where we are with large language models, that information might not necessarily be the most accurate. Thank you from Swapnil. You're very welcome. Nicholas Jones, what service would you recommend for image generation for master planning and schematic or conceptual design? I unfortunately have absolutely no recommendations. I do not know enough about image generation, so I cannot answer that question. From Alan Humphreys, Intel's new Meteor Lake line of Core Ultra processors contain a dedicated AI engine and are available for purchase now. So I think that was maybe to complement my previous answer as to like whether you could run some of these AI models locally. So yes, thanks for that information, Alan. Simon, is Lisp still being used as a programming language for AI, similar from Autodesk? AutoLisp is a programming language designed for the expanding of customizing AutoCAD functionality. It is based on the Lisp programming language whose origins date back to the 1950s. I think Python is the language of choice for AI. I do not know how Lisp kind of like plays into that, but it seems like it's an Autodesk or AutoCAD kind of like it was popular within the Autodesk community, but Python is definitely the language of choice if you want to start programming or interacting with large language models.
Thank you very much, Juste. So if I can just jump in for a second, it's 12:30 and we have reached the official end of the presentation. If some of you members need to leave, please feel free to do so. But I hope, Juste, you can stick around for a little bit longer and try to go through as many questions as possible. Thank you.
Absolutely. Thank you very much for that, Felix. I'll try to go through all these questions. We're almost there. From Paul Vincent, do you have other Ontario building related codes, example, the plumbing code available via Techie? No, we do not at this stage, at this point. I mean, Techie is a little bit of an experiment for us as well. But I think the ability to create other codes would be, like the principle is the same. I think we also have to be a little bit careful because we are using the ELAWS version. And some of these other codes, like, there are certain copyright aspects associated with that. And as I said, I don't know enough about the copyright aspect, but when, I don't know, I've been told to err on the side of caution. So we don't necessarily want to train on those without making sure that we've cleared some of these issues. So there's a question again about the certificate. So after this webinar, how can I have the certificate for OA hours? So please refer to previous answer from Felix.
Exactly, Juste. So again, the attendance of this webinar is reported directly to your transcript, so there's no need for us to issue a certificate.
Perfect. From Aaron Brother, what do you think about AI, using AI for costing construction? This seems like one aspect of architecture with huge databases that is manually processed by cloud consultant. I think it's a great idea. I think that the more, personally at least, I think that the more users we can find and the more data we have available, the better we'll be able to predict some of this information. So I think that the more information, the more use cases we can find for AI and actually start developing prototypes, the better it is. And as you said, like there's huge databases of these costs for buildings, and they make a very good use case for basically predicting what something else might be. Obviously, you have to train the model to understand like nuances, like job markets and economic conditions and all these things that might lead to like unpredictable costs, if you will. But yeah, no, absolutely. And I think that is definitely something that we'll probably start seeing from companies. Now, we also have to understand, like with any field, no field wants to be disrupted or likes to be disrupted. So you're going to start seeing a lot of protection of data, putting data behind paywalls or putting data behind like, things that were previously accessible no longer being accessible, because if you can kind of like start training an AI on something, then you bypass the person that has, taken the time to kind of like collate that information. And, back to Jeffrey's questions, like, how do then, if I made a collection or like a database available on the internet, you train your AI on that database, now you sell a software that predicts costing construction, how do I get compensated for the original work that I did, right? And that is, unfortunately not a question that I have the answer to, but that needs to be obviously taken into consideration. From James Befford, what is a good source for architects wanting insights into AI as a design tool? This presentation is one. So you've done the right thing by coming to this presentation. But on a more serious note, I think that what is going to happen is that you're going to start seeing AI make its way into different design tools, whether that is, Autodesk products. Adobe, for example, already has an AI, I think it's called Firefly, that will help you kind of like, with Photoshop, right? It can do in painting, it can generate certain things for you. If you need certain assets, you can just type it into a window and then it'll produce that asset for you. So I think that we're still in the infancy in the way that, like, even in the interfaces that we have for these AI models, right? Like, we still have this chat box thing, which is really, quite frankly, horrible, but it's the best that we can do to talk to these models. I think that there have been certain applications in the programming world with, like, I think it's called GitHub Copilot, which helps programmers program by predicting, what the next part of code will be, or asking questions about like their code and like generating pieces of code for them. So I think that we're still trying to figure this out, and I don't know what the final thing will look like. But yeah, it's I think that we should just stay tuned and see how it will work. How reliable is Bing compared to ChatGPT? I personally do not like Bing, so I don't use it. So I generally use ChatGPT, but I have no way to compare the two. From anonymous attendee, can Techie source or provide info from other provinces building code, such as the Quebec Construction Code, British Columbia Building Code, etc.? Principle is the same as I said. Right now we're focused on the OBC, but if you're a bibliothèque user, our plan is to release Techie for other provinces, and when that's made available, we'll make an announcement to all our users. From John Lee Doris, I have not been able to see the questions. How do I turn this feature on? Maybe I'll let Felix answer that. I don't know where the questions, if the attendants can see the questions.
Sure, there's a Q&A box at the bottom of the screen from the Zoom at your Zoom window.
And did you catch the resource that Alan Humphreys just mentioned? Yes, so there was a resource, and I think Alan was talking about the Meteor Lake core of Ultra processor, so I talked about that. Okay, that brings us to the end of the questions. Thank you for all your questions, and then I'll pass it over to Felix now.
No, Juste, thank you very much for today's insightful presentation. And now, as we reached the end of the Q&A session, that would conclude today's webinar. Thanks also very much for attending, and please allow me to mention just a few items. The next webinar takes place on January the 25th at 11 a.m. and the title is Understanding Your Role as a Licensed Professional. As mentioned, the OAA will report this webinar to your transcript, so please note there's no need for you to report it as well. And furthermore, for everyone in attendance, the presentation file will be sent out shortly together with a link to provide your feedback. Again, thank you very much, everyone, and enjoy the rest of your day.
Thank you, Felix. Take care. Bye now.